Alright, let's try this again. This should work. Checking my mic. Checking my music. Y'all can't hear it, but I can. And check this out. Boom! I got this calculator on my desktop at home. Or a laptop that I converted to a desktop. Or however you want to cut it. So, bam. Got exactly the calculator. Well, not all of you have, but, now we have something to reference. Anyway, this is one of the reviews. So, again, you can pause the video, try it out yourself. I am not going to make copies of these. And this is from one of the Google forms. So anyway, in the right triangle, ABC. I'm so sorry. I'm eating too many jelly beans. It gives me the hiccups. Angle B and angle B are complementary angles. The value of cosine A is 513. What is the value of sine B? We've gone over this 100 million bazillion times. Whoopsie daisy. I thought I clicked the marker down here. Cosine A, sine B. They're telling you A and B are complementary angles. Therefore, they should have the exact same value. So if cosine A is 513, sine B should be 513. Bubble that answer in. And again, proof would be if we were to draw this triangle. Here's A, and here's B, and this is probably C. C would be 90. A and B, again, are those acute angles. So if I was looking at cosine A would be the adjacent side over the hypotenuse. And if I was looking at sine B, okay, sine B would be the opposite, see, the same side over the hypotenuse. Hence, why those values will be the same. Whoop! This says, what is the value of sine A? Easy. Sine A, remember? Opposite over hypotenuse. A's right here, which means 8 across the triangle would be opposite. 17 is the hypotenuse. And 15 is the adjacent. But since we're focusing on the sine, we need to look at opposite over hypotenuse, which is 8 over 17. Boom. Bubble that answer in. Skadoosh. Given triangle ABC below, boom. Use Pythagorean Theorem to calculate the length of AC. Show your work. Easy. This could be A. Oh boy. Try that again. This could be A. This could be C. Talking about the 13. And then we're looking for B. So A squared plus B squared equals C squared. Let's see. A could be 5 squared. We got B squared. And we got 13 squared. So this is 25 plus B squared. 169. I gotta subtract the 25 from both sides because it's algebra. B squared is 144. Take the square root. And we get B equals 954, 654. Alright, and it should be 12. Should be 12. Bubble it in. I'm on a roll. Again, I'm flying through these because you're supposed to pause the video and try the problem out yourself. Perimeter. Holy moly. You should know what the perimeter means. Of a square is 12 centimeters. Find the length of the diagonal of the square. Circle your answer. Perimeter. It's the boundary of the object. This is a square, so that means all sides are congruent. That's 4 equal sides. What's 12 divided by 4? 3, I know. So if that's 3, that's 3, that's 3, that's 3. Also, fun fact about squares. Diagonals will bisect these corner angles equally. And if they're being bisected equally, that means they're 45 degrees, which means we have a 45, 45, 90 triangle. And if the legs are congruent, as they are, that means all we got to do is tag on a root 2. Because remember your notes, we said leg times root 2 for these 45, 45, 90s. So that should just be 3 root 2. 3 square roots of 2. I think that's correct, right? Yeah, that's the right. Bubble it in. Okay. Another way to look at it, I'll put this in red, is if we focus on 45, and let's say 3 over here is the opposite, 3 over here is adjacent, and the 3 root 2 that, let's say we didn't know was the hypotenuse, we're looking for the hypotenuse. I'm just going to use sine for this one. Sine 45 should be that opposite tree over, let's say, x, because we don't know what the hypotenuse is for right now. And we talked about this shortcut, that this is going to take the place of that. So just swap the two. Save yourself some math headache. And then look, get your handy dandy calculator. Plug it in like you see it. Tree over sine 45, and we get, boom, 3 root 2. That's why I said memorize these formulas. It'll make your life easier, so you ain't got to do the trig. But hey, don't take my word for it. Let's see, we got XYZ here. Again, pause the video so you can try it out yourself. We got XYZ here. If cosine X is 624, angle Z is a right angle. Give possible value of the distances listed below. ZX, YX. All right, let's see. Remember, cosine is adjacent over hypotenuse. So adjacent would be 6. So if we're looking at X, this would be the adjacent side. So that's 6. We got our hypotenuse, which is 24. And they want to know is Z. Well, look, ZX is down here. ZX is 6. YX, well, we knew that. It's 24. And if we wanted YZ, well, we can use Pythagorean Theorem. So let's see, what can we bubble in here? We got 6 and 24. ZX, YX, 24. A little out of order, but that's okay. Wait, check. ZX, 6. ZX, 6. Okay, good. Yeah, bubble it in. I'd hate for you to bubble in the wrong one. Boop. The number value of cosine 52 is the same numeric value of sine what? Remember, these things are complementary, which means they add a 90. So take 90, subtract the 52. And in case this is too much for you, use your calculator. Boom, 38. And we just bubble that one. Boop. You're given cosine theta equals b. Sine theta. I said sine theta. What is that? That's a 30. Equals that bit. Uh-oh. Same ratios. Do you see that? Do you see the same ratios? I feel like a broken record talking about these ratios. Well, if those are the same, what's the value of theta? Again, this, let's change colors for enthusiasm. This and this should be complementary. So if I spent 30, what's 90 minus 30? 60. Boop. I'm on fire. Again, pause the video so you can give these a shot. I'm trying to make sure I don't spend too much time. See, we're at almost 10 minutes. So, let's try to keep this thing going. Let's see, determine the measure angle A. And we got this, and we got that, and we got angle A. That's right there. So we got the adjacent side and the hypotenuse, which means cosine. We should be using cosine for this bad boy. So since we're looking for theta, we need to use the cosine inverse, which means theta and the ratio swap places. So let's see, adjacent, and we got 10, and then we got 25, and that should equal theta. Then you just get your handy dandy calculator, and then just handy dandy move it over so we can see what we're doing. We hit shift, and then we hit the cosine, like cosine inverse 1. Fun fact, fraction key, right there. Plug it in like you see it. 10, scroll down, 25, parentheses, smack that enter button, 66.142. 66 point, we don't need the other one, so just stop at the 4, just one decimal place is fine for degrees. Boom, there it is, bubble in the answer. Boop. Using a triangle below, determine the measure of angle X. So again, focusing on that angle, look across the triangle, we get our opposite side. This 20 is right next to the angle, so it should be adjacent. Then we got the hypotenuse, but we ain't got no value. Probably don't even need it. What trig function uses opposite and adjacent? That's right, tangent. But again, we're looking for the angle, so we need tangent inverse. So I'm going to go ahead and plug in my ratio. 10, 20 should equal theta. Get your calculator back up on the table. And we get shift, tangent inverse, fraction key, 10 over 20, parentheses, boom, 26. That 6 rounds that to another 6. We'll see what the best answer is when we scroll. Oh boy. Ah! Boom! Let's see. 26. Right there. Bubble it in. Boop. Real world applications of birds sitting on roofs of houses, shiny objects on the ground. It's getting real. Okay, we got a bird sitting on the roof of a house, sees a shiny object on the ground, at an angle of depression, 23 degrees. The bird is 82 feet from the shiny object. Shiny. Why does that remind me of something? Hold on. Haha, I'm back. I figured out what it reminded me of. This guy. So shiny. Get out of here. Get out of here. I don't need this anymore. Get out of here. All right. So shiny object. How high is the roof of the house? Got a cough. I don't have the corona. I was just eating too many jelly beans. Anyway, let's see. We got 23 right here. Remember, 23's here. It could also be down here. Well, I guess if you put a 2 first, put it right here. 23 degrees. So, got your picture. Remember, we got a roof, house, bird. I kept the picture simple, but I know you'll like my drawings, so I'm going to just draw a little bird right here. Wings and feet and, I don't know, a beak and I'll make the bird bigger wings. Okay, I'm not that great. You know what? Forget the bird. Point is, bird's on top of the roof. We're trying to figure out how tall it is. Label. We got the hypotenuse. We got the opposite. We got adjacent down here, but we ain't got no values, nor do we care how far the shiny object is away. Shiny object. You know what? I'm going to put him right there. Shiny object. So anyway, opposite, adjacent, hypotenuse. Adjacent, we don't need to know how far the house, roof, on the ground level, shiny, so we don't care about adjacent. Opposite, hypotenuse, probably going to be using sine theta equals opposite over height. Plug in what you know. I know it's 23 degrees. I know opposite's x. And I know it's 82 feet straight distance. Multiply both sides by 82. Those cancel. What you do to one side, you do to the other. Get your calculator. Plug this in. 82 times sine 23 equals 32.03. Let's round that to 4. So 32.04 might be the best guess. This is a feet. Yeah, this is feet. All right, this is my answer. This is what the x equals. Let's see over here. We got anything that's close to this? Nope. Let's see. Let's see. This no, this can't. This just can't be a 9 because the hypotenuse is 82. That's why this doesn't work. It's just one of these two, but maybe 32. So it must be this one. Boom. Boop. Top of a lighthouse, 60 feet above sea level. The angle of elevation from sea level to the top of the lighthouse is 5 degrees. What is the distance between the boat and the base of the lighthouse? Real quick, we got us a boat. Actually, no, we're going to make this one look good. We got the ocean. We got a rock formation of some sort. We got a lighthouse. Okay, it's shining green light. Green light. Like the Green Lantern. For those of you DC fans. I gotta stop eating these jelly beans. Let's see, we're gonna make this a red boat. Okay, let's see. Look at a red boat. We got us a sail. Looking good. Alright, so we got angle of elevation. Making it 5 degrees. Let's see, lighthouse is 60 feet above the ground. Put 60 feet right there. Look at that picture. Magnifique. So, this is 60. That's 5 degrees. We're looking for how far the boat is from the base of the lighthouse. Base of the lighthouse, boat. X goes right there. So label. We got opposite for the 60. X is going to be our adjacent. Here's our height. We don't care about the height for this one. We're more concerned about how far that boat is from these sharp rocks. So opposite, adjacent, we must be talking about tangent. I'm running out of room. I'm going to plug in what I know. I know what theta is. 5 degrees. I know what opposite is. 60 degrees. Adjacent, let's face it, we're looking for it. Probably going to be x. Boom. Again, take the shortcut. Just swap these two bad boys. So x should equal 60 over tangent 5 degree. Get your calculator out. Let me move this over so you can see. Oh, can't cover up my picture. That's too pretty. So fraction key. 60 over tangent 5 degrees equal 685.80. 685.80. It's probably feet because it says feet right there. So let's see. Let's go look at our answers. Yep. Sure isn't this one. Ooh, and circle. Boom. Easy. Skadoosh. An aeroplane takes off at an angle of 5 degrees from the ground. All right, let's get here. Got the ground. We're going to make this airplane red. Let's see. Here's the tail. There's the front of the plane. And then some wings on it. Let's see, we gotta make this a little realistic. Can't see that line because it's top of the wing. Boom, looking good. You know, got a little windshield on the front. Let's see. And I don't know. It's an airplane. You know, you got the rotor tail feather, little props here. It's a mighty fine plane. Oh, and here's the windows for all the passengers. Boom, easy. And it took off. Planes go that direction. All right, so we got our plane. We got taken 5 degrees from the ground. Okay, how far has the airplane flown when it has covered a horizontal distance of 1,800 feet? Horizontal, that's this direction. 800 feet. Draw a diagram, yada, yada, yada. How plane takes off, how far is the airplane flown? How far the airplane's flown? We're looking for this X. How far has it flown? Okay, covered this much distance. So I'll just go ahead and like dot that up so we have a triangle. Boom. Let's see, I'll put it in blue. Angle of reference, which means this 1800, adjacent. X, a height. They're not asking what the altitude of the airplane is. This would be the opposite, so we don't need that. Trig function, cosine. That's right. 5 degrees. Adjacent, 1800 over X. Swap places. Taking the shortcut. X is 1800 over cosine 5 degrees. My calculator. Whoop. Fraction key. 1800. Oh, that's too many hundreds. 1, 2. Boop. There we go. Cosine 5 degrees. I remember when I took off about a month ago, it sure didn't feel like 5 degrees to me. We got 1806, 88, I guess. 88, we'll go with 88. 1806, 88. 1806, 88. I think that's what it said on the last screen. Best answer, right there. Bubble it in. Boop. Man, I am just. Oh, that's our last one. Oh, happy days. Oh, happy days. Oh, I got one for you. Actually, you know what? Oh, wait. Big reveal when we get done. You lean on it. Excuse me. You lean a 15-foot ladder against the house. House. Ladder. Ground. Put the rings on the ladder. House. Evidently, you need to do maintenance on the house. The base of the ladder is 5 feet from the wall. 5 feet from the wall. What angle does the ladder make with the ground? I put a little theta, and it's a 15-foot ladder. All right, little ground in the diagram shown below. Easy. Here's theta, so this would be the opposite. We don't need it. This is adjacent. This is height. We're looking for the angle. Adjacent, height, that's cosine. We're using inverse because we're looking for the angle. So put the adjacent 5 on top, and we got the hypotenuse, which is 15, which is going to equal our theta. Just grab your handy dandy calculator, and you're going to go shift, cosine, fraction key, 5 over that 15. Hit your parentheses, smack that equal sign, 70.5. 7.5, 74.5. That 2 doesn't run the 5. Okay, good. Talking degrees. There it is. Bottom answer. Boom. All done. And I found some more memes here. Because, you know, Moana and whatnot. So I am going to throw something on the here we go. Boom. Hee hee, because I'm so shiny. All right. Good night.